Okay, YouTube, this is part 2 of the M38 assembly, and I guess let's get started. I'll try to be as quick as I can so I don't bore everybody to death, but yeah, stand by and we'll get set up. Okay, we're going to start with our lifters here, because camshaft is usually one of the first things I like to do. I'm just going to smear a little bit of engine blood on these things, get them all lubed up. Alright, this is the last one. Okay, so we're gonna get the camshaft in next, and I'm gonna raise the table up because I don't like to kneel down to work on these things. So stand by. So as you can see, we've already installed our new cam bearing. Here's the trick to these things, and you can't see this, but I'm just gonna tell you and show you that it's there. These engines use orifices to help control the amount of oil that's distributed through the engine. In other words, they're using small holes to sort of like a regulator. Because if you restrict oil in one spot, it increases flow in another spot. So it's critical on these bearings that you get the oil hole lined up so that the appropriate parts can get the oil. Now, these cam bearings can be difficult to get in because they want to rotate as you slide them in. So just to show you that you can see the rod slipping through the cam bearing hole there. So that does show you that the oil holes are lined up. Okay, so let's get the camshaft installed here. Now what I like to do is just put it in backwards for a short time. That way I can get everything lubed up the way it's supposed to be. There's a camshaft. And there's no binding. Okay, that feels good to me. Now, alright, the TM says that the end float of the camshaft is determined by running clearance between the face of the camshaft gear and the thrust plate mounted on the crankcase. The standard clearance is 4 to 7 thousandths, which is determined by the thickness of the thrust plate spacer. Generally, this clearance will change little through wear or even with a new gear installed. Should a check indicate too little infloat, place a shim of suitable thickness between the gear hub and the spacer. Too much infloat may be corrected by dressing off the spacer until required thickness is obtained. Okay, so Basically what they're saying is the amount of float that this whole assembly is allowed to move in and out. So we got to finish getting it assembled so we can check that number and get it where it needs to be. So stand by. Take a little bit of time to get set up for this shot. This is a couple of disclaimers here that, you know, obviously the engine cover goes on before the cam gear goes on, but I don't want that thing in my way, and it's not going to affect my measurements. So we're going to go ahead and get the end plate set on this camshaft so that the camshaft and the crankshaft both want to move outwardly toward the engine, and you have to keep that forward thrust under control by allowing it to move a certain distance. And the call out in the book for this movement or forward thrust is 3 to 7 thousandths. So 7 thousandths would be within tolerance, but I like to keep them just a little bit tighter than that, but not too tight. So what we're going to do is we're going to go ahead and get this set up and get it together so that we can go ahead and possibly get this camshaft in today. So I've got the thrust cover on, and I'm just going to add just a little bit of Loctite, removable Loctite, to these threads. Now this is removable, and I'm putting a star washer in, and I like to do that on all the camshafts just to keep them from working their way out, because this is anything that can cause catastrophic damage. I just take the extra precaution and put Loctite on to keep them from coming out. Alright, so we're going to torque these down to the call out. Okay. Now I'll remove the keyway so I can easily conduct this test. So what I'm going to do is I'm going to slide the cam gear on, and then I'm going to take the lock bolt and I'm going to lock it down in place, just snug it for now. Alright, so I'm going to take a pry bar and I'm going to stick between the engine block and the camshaft, and I'm going to see if the camshaft moves at all. And I feel absolutely no movement. So we can't have that. So we'll have to correct that next. So what'll happen is, if I don't correct this, it'll actually remove material. You can see where it's rubbing already just from that little turn there. So what'll happen is it'll remove all of this material and deposit it into the oil, and metal will start cycling through the engine and destroy the engine. So we got to kind of be particular about these things, because we want this engine to last. So what I've done is cut a shim here, and we'll add one shim. And we'll start the procedure over again. So I got a little movement there. So now that I have movement, I need to know how much movement. So what I do is just slide my chair under here so I don't drop my noga on the floor. I'm just going to take a noga with a dial indicator base, and I'm going to magnetically attach it to the end of the camshaft here. Okay, so we got our noga set up with the dial indicator, and I felt a little bit of movement with one shim. So I want to know how much movement we had, and that looks like 3/1000ths to me, or 2.5. Yeah, that's a good 2.5. So that's not quite enough. So what we'll do is we'll remove the dial indicator. All right, here's the second shim. I'm going to tap the camshaft backwards. I'm going to take my pry bar with the second shim and pry out on the cam gear. And I can see that I am at, looks like 5. Looks like 5. Let's check it again. 5.5. So I'm definitely comfortable with that, and we'll torque this bolt down to spec, and we'll check it again. But I'll do that off camera. I just wanted to show, you know, that the thrust is there, and there wasn't a thrust washer in it when I disassembled the engine. So this may have been another thing that contributed to the engine's failure, because here's the old cam gear. Now even though the teeth are in decent shape on this thing, that's not the only factor that determines whether I replace this gear or not. So when I tore the engine down, I noticed that there were no thrust washers behind the camshaft, and the camshaft had excessive in-play at teardown. So if you flip the gear over here, it's kind of rusty, but you can see grooves cut into this stop right here, and that's an indicator that when the camshaft was put in on the first build, that there was no in-play for the cam gear, or the thrust washer for the cam gear. So what happened is it started to rub and create friction and remove material off the back side of this gear, and that material gets distributed throughout the engine block. So yeah, I could have reused the gear, but you know, I don't always trust these fiber gears when they get some age on them, and there's some clear indications that this gear had an improper thrust adjustment when it was rebuilt. So hopefully we've got that corrected now. So what will happen now that the thrust is set correctly, that will allow oil to get behind the thrust washer and the driving hub of the gear, and will allow it to stay lubricated, which won't create friction and won't create metal debris in the engine. So we made a good call here. So stand by for the next shot.